Hello 108 students, Mr. McHugh back here with you on page 2. Going to keep working on some application problems with rational expressions, and we're going to just do a quick review on objective number 3 concerning how to use ratios that are set equal to each other. They're called proportions. When a ratio is a comparison of two numbers, when they are set equal to each other, how do you solve them? And hopefully you're having a flashback and you remember the concept of cross multiplying. Okay, so what they want you to practice here on this section is cross multiply. You probably have done a lot of these with some very easy. If I say 3/4 equals x over 8, you were going to figure that out. One way is to cross multiply and say 4 times x equals 3 times 8 is 24. There's the cross multiplying. Now to isolate x, divide by 4, x equals 6. And if you put 6 in for x, does 6/8 reduce down to 3/4? And the answer is yes. Okay. Now, over the years, I've always wondered, why does cross multiplying work? And so one informal proof would be to set up a fraction that you know is equivalent. 3/4 is equivalent to 6/8. Again, the ratio of 3 to 4 is equal to 6 to 8. So I give an example. Oh, geez, I was trying to make something. You're supposed to make a mixture of 3 parts. You're cooking some baking stuff. Just pretend this is true. Three parts flour to 4 parts sugar, and you were asked to double the recipe. You'd go from 3 parts, you'd make it 6 cups, and from 4 cups, you'd make it 8. If you had to double a recipe. Okay. So with that said, I'm trying to get you guys to see here that if 3/4 does equal 6/8, does cross multiplying really work? Does 3 times 8 equal 4 times 6? And the answer is yes. 24 equals 24. Now, here's something to think about. Just pull this up here. Go to a different color here. I want you to think about this. Take that same fraction, 3/4 and 6/8, and I want you to say, no, you know what? Let's come over here. Let's say you're going to solve for x. So let me make some room up here. Here's the problem. It's 3/4 equals x over 8. And an alternate way would be to remember, like we did in the last problem, we don't care for fractions. Could we figure out the LCD and multiply it? And so the LCD to this problem would be what? 8 over 1. 4 goes into 8 evenly. So if you multiplied by the LCD, which, you know, when you did learn this in 4th or 5th grade, they didn't tell you that. They just told you to cross multiply, but let's see if we can prove it to ourselves. 4 goes to itself once, 4 goes into 8 2 times. 2 times 3 is 6. And 8 and over 8 cancel out, so you got 8. You have x equals 6, thus we have the same answers we have from cross multiplying. Okay, just wanted to show you that cross multiplying is a fancy way of basically multiplying by the LCD across the equation of the proportion and getting rid of the denominator, or aka if the fractions are gone. Okay, so let's get serious here. Let's do example number 5. Now, there's 2 ways to approach this problem. So I'm going to do it the official way the book has here, and some of you might have some common sense working in your head where you're going, that's a lot of mumbo jumbo. So let's go ahead and take it. They want you to set up these proportions. Okay, so they want you to practice this. You have a car and it gets 10 gallons. You find out it goes 215 miles. You set up that ratio, gallons to miles. For every 10 gallons you get 210 miles. Then you're on a road trip, you're getting ready to take off, you know you're going to like Salt Lake City, it's about 640 miles, you know that's the trip, you've done it before, and you happen to know that you've got 5 gallons of gas in your car tank, and you're trying to figure out how much do you need, how many more gallons do you need to make that trip. So they're trying to get you to set up this proportion, 10 miles over 210 gallons. I've got 5 gallons plus an unknown amount I want to figure out, and I need to travel a whole total of 640. Okay, so once you set up that proportion correctly, they want you to cross multiply. So 10 times 640, that's easy. then you're going to take 210 and you're going to multiply by the quantity. Make sure you remember that quantity, 5 plus x. And that's what's going on here. There's the 210 times the quantity, 5 plus x. Okay, so from here 6,400 equals, and I'll just do the distributive property, 1050 plus 210x. Isolate the 210x term, minus 1050, divide by 210, and all of a sudden you get 25.5 gallons is what you need to go. And also, in class I used to talk about going to Salt Lake City, and you take off, and if you go on a trip and you leave without a full tank of gas. I did that one time going across the Pennsylvania Turnpike with my newborn twins, and I thought I had this 4-cylinder car that was getting 30 miles to the gallon, and I'll get gas whenever. Well, I blew by 2 stops, and next thing I know, we had the long stretch, and my gas gauge was electronic, which was new back in the 80s, mid-80s. I'm dating myself here. It was a Chrysler LeBaron GTS, by the way, if anybody's into the cars. And it was flashing. The symbol was flashing all over the place, and just about had a heart attack, hoping and praying I wasn't going to run out of gas with a set of twin babies in the car. We made it, but I never made that mistake again. But the purpose of this problem here falls back to you realizing that you need another 5 gallons in your car. You need another 22.5 gallons to do it. Now, real quick, I hear that problem, and I'm going to work up here, and I go, there's another way to do this problem. If you go 210 miles to the gallon and you're getting 210 miles over 10 gallons, everybody knows what miles per gallon are, so 210 divided by 10 is 21.21 miles to the gallon. So you say, well, if somebody would say, well, if I knew I get 21 miles to the gallon, I would take 21 times 5, and I would know that I could go 105 miles in my car right now. And maybe you might sit there and say, well, if I can go 105, I get 640 minus 105, leaving me 535 miles. And so maybe you would go this way and say, well, if I have to go 535 miles and I get 21 miles per gallon, just divide the two numbers and guess what you get? 25.5. Okay, I show that way in case a lot of you see it, that you see that fairly, I'll call it common sense. I don't know. I did no algebra is what I'm trying to show there. So if you like that, use it. Go for it. Okay, now number 6 here. We get the famous paddle boats, the paddle boat rivers. I like to say in class, we're down in New Orleans, and there's 2 boats, and I like to draw a diagram. So let me read the problem to you. Problem number 6, page 398, and it says a paddle boat wheeler goes 10 miles against the current in a river at the same time that it goes 15 miles with the current. If the rate of the current is 3 miles per hour, find the rate of the boat in still water. So when I say the boat in still water, think of it as like they set the cruise control on it. What was the steady miles per hour that they set the boat at? Okay, now you can see I like to show tables. I like to draw a river. Sometimes what I'll do here is I'll try to see if I can get this going. Here's my river. Here's a river. And here's the river going downstream is going to be this way. And here's a starting point. And so here's my boat. It's going to go upstream going this way, and then it's going to turn around, come back, and go downstream. Not a very good boat drawer I am. But here you're going downstream. And so I'm told it goes what? How many miles downstream? You look and you go downstream is with the river. You're supposed to go 15 miles. Upstream it went 10 miles. You know you're fighting against it. Anybody getting ready to go on the rafting on the Boise River starts on Thursday, by the way. If you get a chance, I know we're busy with a lot of assignments, but my wife and I love to go on the river, so I encourage everybody to try to get some time to do it this summer. Now, the speed of the boat. They want you to find the speed of the boat, so let that be x. Now, if you're going against the river, is it helping you or hurting you? This is the big moment of the problem. It's hurting you, right? Isn't it slowing you down? And you're told the river goes 3 miles per hour. So x minus 3 would be the speed. What if you're going with the river? you're going whatever the cruise control is set on a boat, but you're taking that and you're working with the river, going downstream. It's helping you, so it's X miles per hour plus 3 miles for the river. Okay, now the key moment in this problem here is it says it took the same amount of time to go upstream as downstream. So what I did in this table was here's your distance. Distance equals rate times time. Don't forget that. Time can be isolated as distance divided by rate. That's a ratio. It can be rewritten. And so we figured out the rate was over here, x minus 3 miles per hour. I explained all that. Now time is up in this column. You're taking against the river, you went 10 miles divided by the speed, which was x minus 3, because the river's working against you. Here it's 15 divided by x plus 3, because I'm taking the speed, which is the boat, plus the river, which is 3 miles per hour. The key moment here is to set these two equations equal to each other. So 10 divided by 10, oh my god, 10 divided by x minus 3 equals 15 divided by x plus 3. Okay, now the big deal to do these problems here, put parentheses around the around the denominators, and then you're going to go ahead and cross multiply. So you get 10 times the quantity x plus 3, then you get 15 times the quantity x minus 3. Okay, now from here you can see the distributive property working, you can see the details, you can combine like terms, and you come up with x equals 15 miles per hour is the boat speed. Okay, and I say still water, that means there's no current. That's all they're trying to tell you there. Okay, I think that's it here. I don't know, hopefully you get that last problem with the boat. The key thing, remember, after you use diagrams, use tables, you set the speed going against the river as the same as going with the river, upstream, downstream, and once you break the ratios of distance divided by the speeds, cross multiply, you're on your way. Okay, I was a little long, but Ms. McHugh, I'm going to check out of here real quick. I will see you for page 3 to wrap up section 7.5. Okay, bye.